of research is cardiovascular science. So anything that has to do with the heart, the blood, the veins, the arteries, and everything, yes. That's my area of research. Interestingly, I didn't wanted to be a scientist. I went to school first to be a biochemist. So my undergraduate degree was in biochemistry. And after that, I didn't know what to do. I was like, okay, I wanted to be a pharmacist. So I went to pharmacy school. So I'm also a licensed pharmacist. I worked for Walgreens for, I think, 5 years. So after pharmacy school, I realized that I didn't want to be the person who just tell people to take their medication, because behind medications, there are a whole team of people who are developing these medications. So I wanted to know what goes into the development of these medications. So whilst I was in pharmacy school, I spoke to some of my professors and I told them my interest. And they suggested that if you truly wanted to know the science behind all these diseases and stuff, you got to go to grad school. So I ended up going back after my doctor of pharmacy to do my doctor of philosophy in pharmaceutical sciences. So I moved from Boston to Indiana. I went to Purdue to do my PhD over there. And once I graduated, I came to Columbia to do my research here at Columbia, New York. Yes. So for me, I realized that I wanted to be on the bench because I wanted to learn, right? I wanted to know the basics of what drives this thing standing here. I don't think there's any machine on this earth which is more complicated than the human body. There's nothing you can tell me. There are scientists who work just for the ear. They just study the ear. There are scientists who just work for the lungs, like we just study the lungs, okay? So it's something that, interestingly, the area that I chose, the reason why I went to that field was because when I was in pharmacy school, it was an area that I didn't truly understand. It was very challenging, so I hated it. So somebody would have run away from it, but I wanted to know what it is. So it was out of curiosity that made me go into that path. And it's fun in the lab because you are studying something that nobody has ever done, right? Whatever you're doing is very unique. You have a team that you work with, but as a scientist, you are mostly the lead. So you are coming up with these novel ideas. Sometimes there's nothing to reference to. There's no end goal here. So you are trying things out based on what you know and based on the work that other people have done. So, for example, when I get to work, I have a team. I have one scientist who is very good with microscopy. So in our work, before a drug comes out, it's very complicated to kind of like explain because it's even more detailed than I thought it was when I got in. So you may have, maybe we are trying to study a disease, right? We have about 20 different scientists with different backgrounds trying to answer the same questions. So you're using microscopy, you're using electrophysiology, you're using different things just to develop one medication. So it's very fun. You get to see the work of other scientists, try to listen to them and see how cool, like the cool things that they're also doing, and you learn. So even though people call me a scientist, I always call myself a student because I'm always learning. You are always, always learning. Scientists are the least confident people you ever see. We are not confident at all. And the reason being that the stuff that we know is far less than what we don't know. So if you're in that field, in your mind, you're like, I don't think I know this because you know what you don't know. The stuff that you don't know is a lot. So you have this like self-doubt that, oh, we don't know. But we're very brilliant people. We are. We are. Oh, setbacks. Well, I think 80% of our stuff are things that don't work. So if you're going to dwell on it, that means that, well, 80 is very low. I think 90% of the time things don't work. So you have to decide whether you're going to be miserable for 90% of the time and then have fun the rest of the 10%. But it's part of science because you are not the only person failing, right? It's all of you. And the thing about that is that it's become like a lifestyle because you are doing something that has now been done, right? Like there's no guideline, so you're trying to come up with some ideas. It takes decades to develop something. So you get used to it. For me, if things don't work, I just walk to my team and I'll be like, well, didn't work. Let's try something else. Sometimes you have to reach out to other colleagues and come up with ideas and try to troubleshoot. So the 10% of the time that things work, it's very exciting. It's like it's the biggest moment of your life. Even the smallest things